All right, so today we will look at Lab 6, and Lab 6 covers the the topic of classes and objects, which is one of the chapters that that you need to read in the book. And before we jump into that, I just want to remind everyone there is a quiz that's scheduled for Wednesday, and that will resemble Assignment 1, as well as all other material that we covered in the class, but the questions will look like the questions that are in the first assignment. So there's a technique in software development called object-oriented design, and it wasn't always used. It was sort of invented at some point. I don't remember, or I actually don't know exactly when it got started. It got started in some kind of seminal form. It wasn't widely used, and at a certain time there was a big transition to object-oriented design. Maybe that was in the early 90s or the late 80s, something like that. And there was a lot of sort of resistance to this in the software development industry. But eventually it just won out, and that's in fact most programming environments that you work in now have a concept of an object, and in most cases the concept of a class as well, but not always. And JavaScript is an example of a language that has objects but does not have classes. And what an object is in C++, in other computer languages, it's you can think of it as an instance of a data type, like you have an int, an integer. So you've got this data type called int, and then you can create, say, an int x and an int y, and these are separate instances of this data type. And in the same way, you've got classes, which are data types, user-defined data types, and then the objects are instances of these data types, instances of classes. And these objects have state and behavior. So think about, let's go back to what an integer is. You might have an integer like, say, you declare an integer int x, set it to 1. Well, it has a very simple state. So its current state is 1. If you increment x, and its state is now 2, the value 2. But objects have more complex state. So you might have a class called point, and maybe the point is it's a point in 2D space. So that point, to specify that point, you need 2 floating point values. So now when you create an instance of that point data type, it has state, and the state is not the value of a single value. It's the group of values, the x position in that two-dimensional space and the y position. So now the state, what the state looks like, what the state comprises, is more complicated. So we could call these complex data types. And then they have behavior. So you'd have something like a point, and you want to, the point is maybe at position 1, 2 in two-dimensional space, and you want to translate that point by adding a vector to it. And so you might have a function that is used specifically for translating a point using a vector. So we'll look at this a little bit more. in code rather than just talking about it. So these are just some general ideas, and I'll try to repeat them, and when you read the book you'll get a better idea what these concepts mean, and you'll start to develop an ability to use this terminology when you talk about programming, when you talk about software design. So let's jump right into Lab 6, Exercise 1. And here, this exercise is about designing or developing. Well, you don't design. I give you the design. I give you the design of a class called WebPage. And your job is to implement that class. And in many cases, although it doesn't have to be this way, but in many situations, the design of the class is specified using a diagram. And this is called a UML class diagram. And UML stands for Unified Modeling Language. And this UML is a collection of diagram types that are used for designing software. And one of the diagram types that's a part of UML is called the class diagram. And here's an example of the class diagram. This is the class diagram for the WebPage class that you need to implement as a part of this first exercise. And these class diagrams have three sections. They've got a section that is just for the name of the class. It's pretty simple. The second section, which is empty here, is the list of member variables. And those member variables comprise the state of the object. So this object actually doesn't have any state. And then the third section in the UML class diagram is a list of behaviors or functions. And so these are things that the class will do. So actually there's no state in this class. It's just a class that's a container for behaviors. So let's take a look at how this works. All right. And also, this problem relates to an earlier problem that we did, which is the Lab 5 Exercise 3. And in that lab, we had we wrote code that would generate a web page. So we're going to reorganize that code and look at how it might appear in an object-oriented design. So let's make a copy of Lab 5 Exercise 3. Let's see if that runs actually. And so this generates a random web page. So we simplified, at least we tried to simplify our solution by organizing the code into functions. So here we have a function that generates a hex string. And here's the main function. So we have just one function, actually. And now what you need to do for this lab and maybe some of the others is to include the UML class diagram in a comment. I think I put that here somewhere. Oh yeah, put the class declaration in a file called webpage.h. Place the implementation in a file called webpage.cpp. And I don't think I asked for a comment there, but I'll put it in there anyway. Alright, let's see. Let's do this. So I'm just going to paste that UML class diagram in there as a way to help document the code. So this is this file here is where we keep the declaration of the class, what the class looks like. And the syntax for that is we use the word class followed by WebPage. And we have opening and closing braces, just like, say, in a loop or a conditional, and followed by a semicolon. And that's easy to forget, obviously. And just to remind everybody, this is a file called webpage.h, and H stands for header file. The header file doesn't have any implementation of functions. It just has the function declarations. And I'll show you what that means in a second. Now there's another file called webpage.cpp. So this is the file that contains the implementation of the functions in the class. Now in this file, what we do is we include the declarations from the header file, which is webpage.h. So you remember the include statement that we've been using. So far we've been using the include statement. It looks like this. Those angle brackets are used to include header files that come with your compiler, the part of the system, a part of the C++ library of additional functionality that is used to extend the language beyond its basic syntax. But now we're using quotes. So because we're trying to include a header file here that's not a part of the system library. Yeah.
And you don't have to include its directory in webpage.h?
Because it's in the current directory.
Oh.
Yeah, that's a good question. Look at the, whoops. All right, this is where I am. I'm in lab 06_1. I didn't save the file yet. So this webpage.cpp is in the same directory as webpage.h. So in fact, that include statement is the compiler will search when it tries to resolve that include statement for any file like this that has an include statement in it, it will first look in the current directory. If it doesn't find it there, it looks in other directories, and those directories are specified in something called an include path. And then to find out what your include path is, you need to dig into the documentation that describes the compiler, and then you can set that include path and so on. And we're not going to need to worry about that at present. So we have this web page class. Let's take a look at what it would look like here. Well, before I do that, let's go back in the main, and we're going to just like this is a problem that we simplified using functions. And this main, in an even earlier exercise, this was our web page generation code was all inside main, so it was a very large function. And we made it smaller so that it actually fits within one screen here by implementing this function, defining and implementing this function, generate hex string. So we took out all of that logic and put it aside in a function so that it made it easier to look at the core logic, the top level logic, without having to look at the details that are carried out in this, that was pushed into this function. So what we'll do in this exercise, we're going to go one step more. We're going to say, well, all right, this is how we reorganize code to separate logic off into functions. let's look at how we might reorganize the code so that it appears like it has an object-oriented design. Actually, to tell you the truth, the example is not that great that I'm showing, because the WebPage class that we're looking at has no state. There's no member variables. So it's just a container for functions at this point. But we'll look at examples where our classes and the objects from them have state. And those will be more typical of what a class would look like that you use to solve problems. Although you can define a class like this as well in real applications, not a problem. So here, maybe we do something like in the main code. I'm just going to start looking at this. We'll do something like we're going to create an instance of WebPage by declaring it like that. So we have the variable name here, and we have its data type. This is like doing like int here. See, we do int I. The data type is int. The variable name is I. Just like that, the data type is WebPage, and the variable name is WebPage. Now they're different. This is a lowercase w, and this is an uppercase w. So a common convention that many developers follow is to start class names with uppercase letters and object names with lowercase letters. So by using the same name here, you can see that, oh, WebPage, that's an instance of the class WebPage. Now, in order to do this, we need to include that header file. And we do that here. So here's the header files from the system, and here's our own header file. So we just put it up there with the other ones. Now you'll notice at this point that the main.cpp includes this header file, but webpage.cpp also includes the header file. So in general, you can have many files that include a single header file. And sometimes you can run into these circular includes. So one file includes another header file. That header file includes a third header file or second header file. And that second header file includes a header file for the first class. So you've got a circular situation there. So that would be just an infinite loop. The compiler would be stuck just pasting in one include inside another indefinitely. So there's the common trick that you see pretty much everywhere to avoid that situation is the following, and I'm going to show that to you. Use a compiler, a preprocessing directive for the compiler. So a preprocessing directive is it's an instruction to the compiler. You tell the compiler to do something. Before you compile, do this first, or consider this first. So if ndef, if not defined, say web_page_h, that's a convention. You see that it's kind of a common convention. So if this symbol is not defined, so if ndef, it's if not defined. If that symbol web_page_h, if that symbol is not defined, then process everything that's in here. Oops, that's lowercase. Process everything that's in here. So if web page H is defined, all of the text between there would not be included when someone is trying to include the file. So when another file tries to include this file, the compiler will look at this directive and it'll say, oh, is the web page H symbol defined? If it's not defined, I'll include everything between the if-ndef and the ndif command. But if it is defined, I'm not going to include any of that that's inside of there. So what we do is this becomes useful only when, what we want to do, we want to avoid including a header file more than once in a particular compilation unit. And so after we enter into this block here, the first thing that we do is we actually define that symbol, WebPage H. So if WebPage H is not yet defined, then define it. And then include everything in here. Then the next time you try to include WebPage H, well, WebPage H was already defined, so we don't process the code that's in between the if-ndef and the ndif statement at the end. So that would, if we did something like this, which could happen, we're going to end up only including one snapshot of that header file. So the second time we try to include it, the WebPage H symbol is defined, and so we skip over all of the code. Now this file here, this is main.cpp. This is called a compilation unit. And when the compiler generates, it reads these compilation units, it reads these files, and it generates machine instructions, the equivalent machine instructions, but not actually all the way. Doesn't generate the machine instructions that can be directly loaded into the computer. It's a preliminary file containing those machine instructions. It's got some extra annotation in it that's used by another process called the linker. That after all the compilation units are translated into these things called object files, then the linker runs, and the linker gathers together all these separate object files that came from the compilation units and merges them all together and resolves the references that they have into each other. So one compilation unit may call function in another compilation unit, and it's the linker that figures out those instructions and how to branch into the function that's in the other object file. So when you think about these includes, that you should think in terms of the compiler processing one compilation unit after another. So when the compiler compiles main.cpp, it will define that symbol WebPage H just for the compilation of this compilation unit. Then when it goes here to compile the webpage.cpp file, it starts all over again. Now the WebPage symbol is no longer defined, it's a separate compilation unit. So when we include webpage.h here, we in fact include the contents that we need. All right. Maybe I'll come back and talk about these as we go along. It's a little hard to explain it all in one shot. All right, so here's the class, and in fact, what we have can be compiled. We've included webpage.h, and we have we get an instance of our data type here. Let's take a look at let's save all these files. I'm not sure if I saved them. Let's see what happens when we build this. I think it's buildable at this point. Now look here, you'll see that you've got main.cpp, WebPage.cpp, and WebPage.h. Now when we build this, we've got our code spread out across 3 files. It's no longer good enough just to build main.cpp. That won't complete the way we need it to. We need to tell the compiler that in addition to compiling that file, you should also compile webpage.cpp. Now we don't need to include webpage.h because, well, there's that directive to include webpage.h inside both of these files, main.cpp and webpage.cpp. So we only need to point the compiler at the files that have functions defined in them. And there it is. The compiler generated the code, and in fact it runs, but it doesn't do anything. Let's look through here. Notice here, these are the functions that are in the web page. There's a function called WebPage, and notice that that function has the same name as the class. And so that will be the case when we're defining what's called a constructor. Constructor contains the code that runs when an instance of the class is created. And here's an example of the constructor. Actually, I will leave this out of here. Here we're declaring the constructor. Notice that we're putting it in a section called public. You'll see there's a section in here called public. There's a semicolon there. There's another section called private. And these symbols here in the UML diagram tell us whether a function is public or private. So plus means it's public, and minus means that it's private. So we've got this. We've got 2 public methods. One is called WebPage, and one is called print. And we declare them like that in the public section. And then we have some more functions here. Get random hex digit and get random color. These are in the private section. And see this colon up here. This following the colon is the type, the return type of the function. This function has no return type. That means it should be declared void. Actually, I need to do that. Print has no return type. And get random hex digit returns a string. Now, we want to make sure that string is defined to the compiler, so let's include the string header. And also, we'll add this code in here using namespace std. So we want to say all of the objects in a string header are defined within a namespace called std for standard. And we just tell the compiler that we want all those names to be imported into the namespace that we're working in right now, which is the default unnamed namespace. No, indentation does not matter there. Just to the human reader, that's all, not to the compiler. Here we go. Here's the implementation file. This is the file webpage.cpp. In here, we need to provide implementations of these functions. So it'll look something like this. You'll have a function called WebPage. It's a constructor. And here we have a function called print. And when you define a function, you need to have those braces that enclose the statements that are executed when you call the function. When you declare the function, you don't have braces. You're just telling the compiler a function exists by this name. Yeah.
How do you jump from another file into this file?
When I'm using a tool called Screen, I can show that to you later if you like. I use Control A spacebar. It's just a utility that comes with Unix operating systems. It's usually not pre-packaged with the system. You have to install it. All right, so I can show you more about that later if you're interested. So here are the functions. Now let's create function stubs. This function needs to return a string. So let's return a string, just an empty string. Here it will return a string. Print doesn't need to return anything, so we're okay. And WebPage constructors don't return anything, so you don't declare them as having return types. But one thing is, when the compiler sees this code, it sees a global function called WebPage. Here it sees what's called a global function print. So anybody can call print anywhere. But we want to tell the compiler, no, this is not a global function. It's not an ordinary function. It's a member function in the WebPage class. So that means we use this syntax. We qualify the function name with the class name. Class name followed by two semicolons, or two colons rather. And this tells the compiler that, yeah, this is a print function that's declared in the WebPage class. That's what we're implementing here in this file. So we do that with all the functions. And notice this qualifier here is attached to the function name. So it will come after the return type. So there we have a class called WebPage. It's declared to have two private functions and two public functions. And we declare the existence of those functions in the header file. But in the implementation file, the file that ends with .cpp, we actually provide the implementation of the functions, which are stubs at this point. They do the minimal amount of work in order to get the program to compile and run. Let's see if it runs. Now let's see if it compiles and runs. And so let's look at print. Let's just say let's just print OK here. Maybe that's what the web page looks like. Now to use cout, we need to include the header file for that, IO stream. And let's invoke that function print. I'm going to comment out all of this stuff so we see it run. And just call print here. So we have webpage dot print. This is the syntax. We have the name of the object, dot, followed by the function name, and then the arguments. And print takes nothing here. Let's run it. Oh, it says it says OK, but it didn't put a new line in there. Let me do that. Oops. That didn't work. What? Oh, I see. Caps lock. There's the OK. Okay, so that's how you call a function on an object. You create the object and call a function. Look at this. We can put, this is the constructor. Our constructor does nothing, but just to show you that it's in fact invoked, let's do this. That when the constructor runs, we'll print constructor calls. You can see the constructor is called before we call print. We call print at the very end of the function, at the program. Here, this is where the constructor runs. When we create an instance of the class, we're running the class's constructor. So when we run the constructor, we print the message. So that's how we're testing, see what's going on. All right, now, but let's do this a piece at a time. We're going to want to move these output commands into that print function for the WebPage class. And we don't need this anymore. We need them in here. So instead of printing OK, let's start printing the WebPage. So we move these out of here. I'm going to take those out. And let's get the rest of these. So we've moved these out. We've put all of this code into that print method. So now our main looks like this. It's just 3 lines. Create an instance of WebPage and then print it. But we do have this. We have this logic up here, which generates the hex string. We need to move that into our WebPage class. In fact, look at this. We're calling it here, but this function is not defined yet. It's defined inside main, but we don't see that over there. We look at the header file again. Here's the function get random hex digit. It's now a member function of the WebPage class. In fact, this code in here goes in there. Let me grab it. This is print. This is get random hex digit. Well, this is the hex string, isn't it? This is a little different. So I have to change things a little bit here. I'm just going to pull it over a piece at a time. I don't remember if I got that piece or not. I'll try that. Nope, I did 2 of those. Nope, okay. All right, we moved that logic over there. We don't need it in main anymore. Let's take this out. So you see inside main, we seed the random number generator, create an instance of WebPage, then call its print method. That's it. That's essentially what our program does at a high level. So here's our print function. So the constructor doesn't do anything, but the print function does the work in our example here. And so the print function actually calls this generate hex string, but we didn't define a generate hex string. You know, I'm thinking about changing the example. Let's change it. I think I'm going to change the question to make it easier to do this, what we're talking about now. And this is what I'm thinking. This is get random hex digit. This should be generate hex string. This is so we don't have to do too much extra work. Generate hex string. So we're going to, this is all we need. I mean, looking at what we've done already. We could do it the other way, but just I want to show the equivalence between all three solutions to this problem. So we have a solution that just has all the logic in main. We have a solution that defines a function called generate hex string. And now we have a solution that puts all the logic inside of a class. So I think I'm going to change that. And the instructions on this. This is generate hex string. And this doesn't change. This is the WebPage class. This should be generate hex string. That returns a string. And we've taken this out. Now it should be good to go. Now inside this function print, we're calling another function which is a member function of the class called generate hex string. That should work. Oh, doesn't work. What's the problem? Yeah, we need the header file that has a definition or the declaration of rand in it. So we're using rand in here, and I think it was C standard lib. Is that it? C standard lib. I think that's it. Or was it C math? Okay. C standard lib. There, that was it right there. Okay. You could see that. See, error right there. Even give the line number, line 39, column 20, line 39, error. Rand, you can forget the A hats, that's supposed to be a quote. Rand was not declared in this scope. So we went back and we added the include C standard lib, so now that rand was defined. And if we run the code, there we have it. That's it. Now once again, I'm going to change the instructions on this. I'll just do it real quickly so when you go to lab you'll have it. There should be generate, was it generate hex string? Just like that. Whoops, 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 whoops.
Is that generate random color or is it get random color?
Get random color, but we're taking it out.
Okay.
And is that what I had? Generate hex string? Wasn't generate random hex string? What did I have? Generate hex string, that's it, okay. And then, whoops, what's going on there? I want to take this out here. That doesn't work. This simplifies the problem a little bit because it's basically making it equivalent to the earlier exercise. So this is generate, the function generate random hex string. Generate hex string rather. No, we don't even need that in there. We don't need that sentence in there. I'll look at this later, make sure everything makes sense. But that's that. Oh, look at that. Okay, thank you. Now, I want to get rid of this, though. I mean, how can I get rid of that? This is Google Sites. It's really convenient. It takes a while to learn, but it's fantastic. It's free. And I've been running my own web server and wiki for years, and this is so much easier. I don't have to do any system administration when the server goes down over the weekend. I don't have to come in, fix it. So that's that. And now there's a version 2 here. I think what we'll do is maybe look at that next time. You can look at it in the lab. And there's still quite a bit of time left. And I was thinking about showing an example of a object-oriented program that I used in the previous quarters that were on quizzes in previous quarters. Let's see. This is, I think it's a better motivating example. I like what we did today because it shows, it works with code that you've been working with already on 2 previous labs. But it doesn't really illustrate this idea of state, that instances of classes or objects encapsulate state. And but that's covered by this example, which was on last quarter's quiz. So we have an example. We have a class called beanjar, and we create instances of beanjar to represent real bean jars in the real world and how many beans that they actually have. So you've got a class here called a beanjar, and it has a public section and a private section. And in the public section, there's a constructor. This constructor takes 2 arguments. The first argument is the maximum number of beans that are in the jar. The second argument is the initial number of beans that are in the jar. If the jar takes 10 beans, but you want to create an instance of a jar that has 5 beans, it's half full, then you would call it with you would call a constructor with 10 here and 5 here. And then you've got these behaviors or operations. You can add beans. So once you create a bean jar and you have so many beans in it and you have a capacity, you can add additional beans. Or you can remove beans. And if you're not sure how many beans are in the jar, you call the function get number of beans. And that returns the value, how many beans are in the jar. And now for this class to work, for these operations to make sense, you have to keep track of the number of beans. And you have to have a record of what the capacity of the jar is. You need 2 values. And so those 2 values are declared in this private section. there's a maximum number of beans held by the jar, that's an int, and that doesn't change. When you create an instance of bean jar, that value is passed into the constructor, and the outside code can't get at this, so it cannot modify the capacity of the jar. If you want different capacity, you have to create a new bean jar instance. And then there's that other variable, which is also an int, and that's the number of beans. That outside code can modify. So the outside code doesn't directly modify number of beans because it's private. That means the compiler will not allow code that's not in the class, like code that's in main, say. If you suppose you have your code in main, and your code in main wants to change the number of beans in the jar, you can't just reach in there and modify the number of beans directly. The compiler doesn't allow that because it's in this private section. So to modify this value, you do it indirectly by, say, removing beans. So you have to call this public function called remove beans and give it how many beans to remove, or you can add beans. The other thing to keep in mind about this is when we did this on the quiz, I didn't use a header file. So let me just show you how to do that. We can just paste this into a file. Let's do that. Okay. That's that screen. See this? I'm not running screen now, but if I run it, now I can go into, I can do operations in this one screen, then I do Control A spacebar. Just created a new screen. Oh no, it didn't. Control AC, I'm sorry, that's for create screen. Can go into bean jar. And then if I do Control A space, I go to my other screen. So I can have any number of screens open. Just rotate through them. It's very convenient when you're in a terminal window. That's good when you're doing system administration and you're like working on a remote server somewhere. But for software development, you wouldn't really write code. The way we write code in this class, you wouldn't normally write code that way. You would use an integrated development environment, like a Visual Studio or Xcode, right? So you wouldn't need to use screen. So let's grab this here. There's a whole program right there. And paste it in here. I wonder if it just builds. Let's see. It does not. First argument int main should be an int. Oh, I got that reversed. No one noticed that on the quiz. I'm just kidding. Not really an important. This argument list I think is optional usually. There we go. Okay, great. So so what we have here is a single file, main.cpp. We didn't create beanjar.h and beanjar.cpp, but we could have. And actually, that's the standard organization when you work with classes in C++. You have a header file, you've got your class file, your implementation file, and then you just have lots of those. So you'll maybe have 20 classes, 100 classes. You've got 100 header files, 100 CPP files. Something like that's the normal architecture. But it's possible just to put everything in one file. That's what we did here. So we have our includes here. Then we have this comment section, right? So documentation. We declare the class here. And oh, we do have separate implementations. So we have the class declaration here, and then we put that semicolon here. But in fact, it's possible just to put the implementation right in here. So you could, for instance, do something like this. And then you would take out the implementation that's defined there. So it's possible to organize your code in different ways. So what we did in the lab is the most common organization of the code. So we've got our bean jar constructor. It takes these two arguments. We've got add beans function, remove beans, get number of beans. There's a special name for this function here. It's called an accessor method. It basically returns the value of one of the member variables. So we can't get that member variable directly, and that's a convention. You know, we could have declared number of beans in the public section. And then outside code outside the class could then access it. But by convention, programmers will put these state variables in a private section and restrict access to them through accessor functions. So you notice there's a get number of beans, but there's no set number of beans. Of course there could be. But when you write code, when you develop a software system, the rule is don't provide more functionality than you're going to use. So there's no case for directly setting the number of beans in this hypothetical solution that we're working on here, this hypothetical problem that we're providing a solution for. So if there's no in our solution, in our design to solve this problem, this hypothetical problem, it doesn't make sense to let outside code directly set the number of beans. We want the outside code to go in through remove beans and add beans. And that's why we only provide, this get function through what's called the public interface. And we don't provide a set function. Here's the constructor. Now notice in the constructor the two arguments have exactly the same name as the member variables. So we have some way of distinguishing between those. The member variables, if we prefix those with this hyphen greater than, which looks like an arrow, that tells the compiler that this expression here should be the member variable max number of beans and not the variable that represents the first argument to the constructor. Here, max number of beans appearing in here is not prefixed by this. That means it's refers to the name that's being passed in as an argument. Later you'll learn about this. We won't learn about it in this class, but this is a pointer to the object instance itself. So that's how that works. And that's not just C++. You'll see that in pretty much all object-oriented languages. Oh, here's the problem. I see. This is the quiz problem to implement add beans. So if someone calls add beans, passes in the number of beans to add, we need to write the code to implement that function. Remove beans, well, I show that code here. Number of beans to remove. And the reason for this extra logic is, let's suppose you've got 5 beans in a jar and someone's telling you to remove 6 beans. Well, that's 1 bean too many. So let's handle that case. That's what this logic does. Let's look at the main. This just shows you what it might look like. The how you might use this class. Here in this first line, here we have the variable name being jar preceded by its data type being jar, in uppercase B. And then we need to, this is an invocation of the constructor, but the constructor that we have for this class takes 2 arguments. So we need to list the arguments like this. It looks like a function call basically. So the capacity of the bean jar is 10 beans, and the initial number of beans in the jar is 5. And then we're just, we're testing our code. So this is called a test harness. It's just a main function. The purpose of it is to validate the logic that we have that's, that implements this function, that implements this class. So if we call get number of beans on our bean jar, it should return 5, because that's how many beans are passed in here. And if we call add 3, then when we call get number of beans, it should return 8. Remember what the capacity of the jar is 10. We currently have 8. If we go try to add 4, we currently have 8 beans in the jar. When we try to add 4, it's going to refuse to. It won't turn to 12. 12 will be an error because the jar can only hold 10. So actually, it looks like add beans returns a Boolean value. Is that right? Oh, so I return a bool, right? Oh, so the bool, look at this. This bool here, here's remove beans, returns a bool. So it returns true if the operation succeeds normally, and it returns false if there's a problem. Look at this. So if the number of beans to remove is bigger than the number of beans that are in the jar, then we let the caller know that there's a problem there. Wait, we couldn't remove that many beans, so we return false. That's our signal to the calling code that the operation didn't succeed. So after trying to add 4 beans to the jar that has 8 but can only hold 10, the add beans function says, I can't do it. I return false. And then after that, the call to get number of beans should continue to return 8. So we test that here. And there's, here's another problem that's done on the quiz. So this is an example of a class that has state in it.
Is that why the exclamation point is there? Is it a Boolean?
Yeah, it returns a bool. So this should return a false. We're trying to add too many beans. So the function is going to say, I can't do it. It returns false. But if we just pass in false to assert, that'll trigger the assertion failure here. So we'll terminate execution at this point with a failed assertion message. So we know, we're the ones that are testing the code. We know it should return false. So we're asserting that what it returns is not true, right? So we take the false return value, convert it to a true, so that assert now just quietly returns without doing anything. Get number of beans does not return a Boolean value. It returns an int. That's why we're comparing it here like that. We could also do it like this. Maybe this is more clear. Watch this. Here's an alternative. Add beans, just like get number of beans. Get number of beans returns an int. Add beans, in fact, returns a bool. And we think it should return a false. So we could do it like that. Maybe that's easier to read for you. That's okay to write it like that. Certainly you want to write it the way that's the most expressive and the easiest for yourself to understand, and also for the people that you're working with as well. Okay, so I covered a lot, and you work with this, do the reading, and solve some problems, and get a feeling for object-oriented design, and you'll take that knowledge into other contexts like JavaScript or C# or PHP or whatever, and be able to understand what you're doing in those other languages. One question here.
Quiz on Wednesday.
Quiz on Wednesday. Quiz on Wednesday. Practice the assignment. Don't memorize the answers. Put the answers aside. Try to rederive all those answers on your own without looking at the answers that I gave you.
It's going to have classes on it?
Huh?
The quiz is going to have classes on it?
No, no, the quiz does not have classes. It resembles the material that's covered up to that assignment 1.
Oh,